All right, listening please. You might remember when we did expansion, we did common factors and then we did FOIL next. And then you're probably wondering, why did we skip over FOIL when going backwards? There's a reason for that, okay? It's the harder one, but it also applies to everything. So I'm going to tell a story here. I've taught you common factors. I've taught you difference between two squares factorization. I just did perfect squares factorization. But you're going to encounter questions like this where none of those work. Let's see why it doesn't work. Is there a common factor in x squared, 7x, and 6? Is there an x in all of those? No. So common factors is not going to work. You're going to try difference between two squares. But difference between two squares only works when there's two terms and there's a subtraction between them. Is that two terms with a subtraction between them? No, that doesn't work either. So you've been like, Mr. T, why'd you teach us these if none of them work? Okay? This last one, perfect squares. Are there three terms? Yes. Are two of them square numbers? This one's a square number, but 6 isn't. So all of our different tools have failed. I've used a Phillips head screwdriver, it didn't work. I used like a wrench, it didn't work. So the last tool is actually the opposite of FOIL. It's called sum and product factorization. It's actually my favorite, and this should be freaking you out right now, but when you try it out, it's not too bad. It'll be your preferred one. Why is it called sum and product factorization? If my quadratic looks like this, x squared plus px plus q, if I have two numbers that times together to get q, that's what product comes from, that's why it's called sum and product. And if I have those same two numbers add together to get p, it factorizes to this. And okay, I agree. That rule doesn't make sense right now. It will when we do an example. So can you get the rule down to start off with? And then I'll go through the steps. And then your concern will turn to lack of concern because this is the nicer one. This always works. Okay? Unlike the other methods.
I'm just going to use one.
This one, you'll be using this many, many times. If you do methods or above, you'll be using it many, many times as well. Right where you see.
I see like a gibberish. How do you know A times B is equal to Q and A plus B is equal to...
You'll see when we do an example.
Okay.
How are you going to know what your A times by B is Q when we don't have a Q right now? The Q is there because it could be any number. When we do an example, you'll see.
Okay.
You'll see again, first step is check if you remove common factors again. It's always the case. Okay, I sense the worry and that's fine. As soon as you see an example, it clears up a little bit. It's like the clouds will part on a cloudy day. So step 1, check if you can remove a common factor. That's been the case for all of the factorizations. Step 2, make sure your quadratic looks like this. It has to be x squared. It doesn't have to be p, it just has to be something px and a q. List pairs of factors that multiply to get that q. Choose one of the pairs that will add up to make p, and then you apply this rule when you've decided what a and b are. So that you're less worried, let us do those steps very slowly here. I'm going to write that down, x squared plus px plus q. What number is q right now? 4. Step 3. List pairs of factors to get Q. What can I times together to get 4? 1 and 4 and 2 and 2. We've done this, this, this. 4. Choose a pair of the factors that add up to make P. Are 2 and 2 going to add up to make 5 then? Is 1 and 4 going to?
Yes.
So 1 and 4, A is 1, B is 4. So now I can apply this rule. You just factorize it to x plus, what did we say A was? 1. What did we say B was?
4.
X plus 4. That's it. If you want to double check, what's x times by x going to be? Let's FOIL it out. X squared. What's x times by 4 going to be? 4x. What's 1 times by x going to be? 1x. What's 4x plus 1x going to be? 5x. And what's 1 times by 4 going to be?
4.
See how it reverts it back? So, as you've learned over this while, I get the steps down because they'll always work, but they don't necessarily make sense until you try one. Okay? Can you get that example down, please? Because is it as worrying as...
No, I just remembered we did this last year. This is the test that
No, we did not.
Oh, we didn't.
Yes, we did. We did this last year.
What,
We
Miss
did.
Crucial made us like list all the factors and see which would times to like 1 and then would
Oh,
plus
I do remember.
But you're going to use it in context now. Okay? Can you get that example down? We'll do harder ones. Why is it called sum and product? Did you find the products?
Yeah.
Did you find the sum? The reason why we need to do multiple examples is because these don't need to be positive. You can have combinations of minus and plus. Okay? That's the hard part. You guys not the best at negative numbers. But also you deserve credit. I've never given away the prize in the first test. And I've never had 300%.
We should all get one actually. Just saying.
Okay.
It sounds like something someone who came second would say.
Well, I'm sorry, but I actually got like 100% on the first try.
Keep going. Oh, I thought about it. I'll rerun it for the quadratic test because I feel like the quadratic test is. I'll put it up again, but you won't.
Oh.
I won't allow you to. Can we do a harder example, please? What was that? Is this written x squared and px and q? There's just negatives. Okay. What are the factors that can multiply to get 12? You tell me. 1 and 12. Next.
6 and 2.
2 and
6.
6. Next. 3 and...
3 and
4.
4.
the next one's going to be 6 and 2. So we stop there. What combos, remember positives and negatives apply, I need them to add up to get negative 1. Am I ever going to get negative 1 by adding and subtracting 1 and 12? The best I can do is 13 and 11 with 1 and 12. What's the best I can do with 6 and 2? I could get 8 or I could get 4. Can I get 1 with 3 and 4? What combo of positive and negative do I need to do with 3 and 4 to make it negative though?
3 minus.
Negative 3 plus 4 is going to be positive 1. I want negative.
3 minus 1.
Yeah. So if I do, so what's my A? 3. What's my B? Negative 4. Because 3 plus negative 4, what does that give you? Negative 1. So what's my factorization? X plus 3, X minus 4. There's always hesitation at the start, but this one's kind of fun because you're searching through the factors. Okay. Last one. What was step 1 that you always try when factorizing? You don't try to factorize straight away. You try to remove what? Is there a common factor across all of these 3?
2.
Let's remove negative 2. If I've removed negative 2, you're going to have x squared, negative x. Why is it negative x?
Positive.
Negative 2 times by negative x is going to give you positive 2x. And negative 6, I believe. So this is what I'm trying to sum and product rule. The one in the brackets. What are the factors of 6? 1 and 6. Next, 2 and...
3.
2 and 3.
Am I ever going to get my negative 1 that I need in the middle with 1 and 6? I can get 7 and get 5. Can I get -1 with 2 and 3? What combo of plus and minus could I do with 2 and 3 to get -1? 2 minus 3. So what's my A going to be? The actual order of your A and B doesn't matter. I just need these two are A or B, okay? I just do it in the order that we read. So x plus 2, x minus 3. Is that the answer, or am I forgetting something? The -2's on the... You'll lose a mark if you don't write that. So that's good. I don't forget the -2 you removed as a common factor there before. That's the end. That's all your test covers. It's all up to that. There's no special worded special topic to do worded problems there. There are worded problems, but they're harder in the practice than the real thing, okay?